Question number 10, section B. A shop sells a chocolate. The weight in kilograms of chocolates bought by a random customer can be modeled by continuous random variable of x with a probability density function f defined by this piecewise function. So any random customer will buy chocolate minimum of 0.5 to the maximum of 3 kilogram. Otherwise, it's 0. Find mode of x. So mode of x is where the highest probability happens. So what we need to do is we need to draw a function. So this one. So this function here, probability density function defined by 6/85 times 4 plus 3x minus x squared. This probability density function. The function is only defined from, domain is restricted from 0. X is greater than 0.5, second test logic, and x second test less than 3. So domain is restricted like this. Go to graph, and then the function looks like this. Find the mode of x. Mode of x is when the highest probability happens. So the max value of this function. So mode of x is using the GDC mode of x. Mode of x equal 1.5. Find the probability x is between 1 and 2. So this function, we go to second quit, and then math integral from 1 and 2, the probability density function, this one of dx. This is the probability. So this one is 0.435. Find the median of x. The median of x is where this integral from left left range is 0.5 to median of x, m f of x dx. This value becomes exactly 0.5. That's definition of median of x. So go to y3 function, go to mass integral from 0.5 to median x, and this function of PDF function dx equals 0.5. So I'm gonna to minus 0.5. I just need to find the zero of this function. So again, it's not, doesn't show anything. It takes time. Okay, so I need to find zero of this function. So come on. Yeah, okay, 0 is an x equal 1.69. So that is m value. Mode of x is, the median of x is 1.69 kg. The shop sells chocolate to customer at $25 per kilogram. However, if the weight of the chocolate bought by a customer is at least 0.5 kilogram, which is more than 0.75 kilogram, the shop sells chocolate at a discount rate of $24 per kilogram. Find the probability that the randomly selected customer spent at most $48. In order for randomly selected customer spend at most $48, this means the customer bought a chocolate of 2 kilogram, right? because he bought a 2 kilogram, the shop will give the customer a discount rate of $24 times 2 equals exactly $48. So this question, find the probability that the randomly selected customer spent at most $40 means, so it's probability, so find the probability x is greater than at most, so x is less than 2 kilogram. Probability x is less than 2 kilogram, then he only gonna spend $48 at most, $48 and less than $48, right? So this value is exactly equal integral x is from 0.5 to 2. It's from 0.5 to 2 f of x dx. We need to find this value equal math integral from x is 0.5 until 2 kilogram f of x dx. Math integral x is from 0.5 oh shit, math integral, put the y2 over here, and x is from 0.5 until 2 kilogram dx. So the answer will be 0.635 by 3 significant figure. Find the expected amount of spend per customer, give your answer correct nearest. So the expected amount of spend per customer, let this value defined by y. So the expected amount of amount spent per customer, y, can be defined as this piecewise function. Y will be initial value was $25 of x when x is less than 0.75 kg. So it's not included. So x is less than the x random variable x is less than 0.75. The amount of expected amount will be 25x. When x is at or greater than 0.75, it's going to be $24 per kilogram, so 24 of x, right? So we want to find e of x, expectation of y, e of y equals integral of this all function from all domain, in all domains. So it's going to be integral, x is lowest value here actually is 0.5, so it says 0.5 over here. So from 0.5 to 0.75, y is 25x of fx. So it's going to be, I'm going to put this x, 25x of fx dx, plus when y is more than 0.75, so 0.75 until the maximum amount is given in the question is 3. 0.75 to 3 is going to be $24 of x. This is spent the customer. This is the expenditure that the customer used of fx dx. This is e of y equal GDC. So mass integral from 0.5 until 0.75, 25x fx equal y2 d of x plus integral from 0.75 until 3 of this time it's $24 of X expenditure of FX Y2 and DX. So this will be the expected amount of expenditure. So that's $40.96. So it says correct to the nearest cent. So second digit below the dot. So it's gonna be $40.96. Yeah, this will be the answer.